Dear colleagues and guests, my name is Aidan Hurka, Assistant Professor PhD from Technical University of Varna, Bulgaria, Faculty of Computer Science and Automation. Today, on behalf of our team, I will represent you comparative analysis of ZigBee 6LoWPAN and Bluetooth Low Energy technologies for the Internet of Things. 4G provides the foundation for 5G connectivity. In most cases, the two technologies will be closely integrated and will coexist. During this decade, 5G will continue to improve, but 4G technology will develop along with it. This can be seen in Ericsson's mobility report of June 2021. Internet of Things technologies rely on 4G and 5G infrastructures that can meet their needs by providing high-speed and reliable communication. Use case model from ITU published by 5G Americas shows different use cases for which 5G will improve speed for applications, supported number of Internet of Things devices, the dependability, and minimizing network traversal time. The widespread expansion of Internet of Things requires the study of various technologies in the field. ZigBee, 6LoWPAN, and Bluetooth Low Energy technologies are most popular. The research of the considered technologies can be carried out through real network construction. The aim of this study is to present the same experiments through build network for considered technologies for realization of comparison between technologies and also formulation recommendations for using specific technology. The idea is to study the throughput, end-to-end delay, and packet loss ratio parameters for ZigBee, 6LoWPAN, and Bluetooth Low Energy technologies for each Texas Instruments CC2650 STK sensor nodes in the realized experimental network, then to compare obtained results from the experiments with static sensor nodes which are located at different distances from the network coordinator. Finally, as a result of the research, to formulate recommendations for the most appropriate technology for building a sensor network for Internet of Things with the used sensor nodes. The experimental studies for the considered technologies are realized with different number of simultaneously connected in the network static sensor nodes, which are 2, 4, and 6. The experiments include calculating the values for the parameters end-to-end delay, throughput, and packet loss ratio, which affect the quality of service, and distances between the sending device and the sensor nodes of 1, 2, 3, 4, and 5 meters when sending 5, 10, 15, and 20 packets. In order to ensure comparability between the obtained results for the studied technologies, a star topology was used in all experiments, where one visualizes serving device with transceiver and two the end sensor nodes. BeagleBone Blackboard with installed operating system Bone Debian 9.9 is used to the construction of a physical ZigBee and 6LoWPAN network. To work as ZigBee coordinator, the board uses ZStack Linux Gateway software and Contiki 6LoWPAN border router software to work as a 6LoWPAN gateway. A Texas Instruments transceiver CC2531 EMK is installed on the BeagleBone Blackboard to communicate successfully with the sensor nodes. The transceiver can be configured to work with ZigBee or 6LoWPAN technology. The Bluetooth Low Energy network is constructed with the Raspberry Pi 4 Model B development environment with the Raspbian operating system to work as a Bluetooth Low Energy master device. Communication with the end sensor nodes is carried out with a built-in Raspberry Pi board Bluetooth Low Energy transceiver. Texas Instruments multi-standard sensor nodes CC2650 STK are used to perform the experiments. These sensor nodes can be configured to work with ZigBee 6LoWPAN or Bluetooth Low Energy technologies. The values for end-to-end delay, throughput, and packet loss ratio were calculated using equations from previous work. According to first and second equation, P is all processing delay, LRQ is length of request, LRS is length of response, N is number of successful request response pairs, and T is total time of simulation. Throughput values are converted from kilobit per second to bit per second. According to the obtained results, the values for end-to-end delay increases with the number of end nodes in the considered technologies as more time is required to serve the requests of all devices. As the number of packets sent increases, so do the values obtained for end-to-end delay as there are more requests for serving on the network. With ZigBee, in most experiments, the minimum and maximum values for end-to-end delay is better than 6LoWPAN and Bluetooth Low Energy. In addition, in most experiments, the values obtained for ZigBee and are constant and do not change drastic with increasing distance between the end nodes and the serving device. Based on the obtained throughput results in 6LoWPAN with increasing the number of devices, the reported values for the lowest priority node decrease. With ZigBee, the results for the lowest priority node are kept at the limit of 5000 bit per second. Bluetooth Low Energy provides greater throughput with increasing the number of end nodes compared to ZigBee and 6LoWPAN. For the obtained results for packet loss ratio, it can be seen that the values increase in direct proportion to the number of nodes in the network for the considered technologies. The following recommendations can be formulated for the experiments and the results obtained. In applications where it is important that the values for end-to-end delay are relatively low and constant, it is better for sensor nodes to be configured to work with ZigBee technology. In applications where constant throughput values are required, it is better for the CC2650 STK sensor nodes to be configured to work with ZigBee technology. When required to provide higher throughput with a larger number of nodes in the network, it is better sensor nodes to be configured to work with Bluetooth Low Energy technology. In applications where less packet loss is required, it is better for sensor nodes to be configured to work with ZigBee or Bluetooth Low Energy technology, as the packet loss ratio values obtained are extremely close, with lower values obtained for ZigBee. As a conclusion, this paper compares the influence of different technologies for sensor Internet of Things networks, which are ZigBee, 6LoWPAN, and Bluetooth Low Energy, on quality of service parameters, end-to-end delay, throughput, and packet loss ratio. The values for the studied parameters in the considered technologies were calculated under equal other conditions. Based on the results of the performed experiments, recommendations for the choice of technology formulated according to the specific requirements of the applications to the quality of service of the network. The results of which are presented in the present paper, have been carried out under the National Science Program, Young Scientists and Postdoctoral Students, Part 3, which is financed by the state budget. Thank you for your attention.